Assalamualaikum warahmatullahi wabarakatuh. We are from day 4 EC110 for day 1. We're gonna present Civil Engineering Materials Project 1 Sustainable Products. Okay, for introduction, in this assignment we will pick 2 articles from past 5 years about sustainability of civil engineering materials. We are more focused on concrete. Sustainability means the needs of the present without compromising the ability of future generations to meet their needs.
Basically, Article 1 is about green cement application utilization in building project. The researcher performed 2 tests, which is laboratory test and field application. In laboratory tests, they perform 3 types of tests, which is setting times, compressive strength, and shrinkage. At the end of this test, they can conclude that greener cement gains strength between 11% and 30% more than Portland cement at standard curing period of 3, 7, 14, and 28 days. In this article, the researcher always questioned did well-proportionate greener cement gain strength more than Portland cement at standard curing period? The objective for this studies article is to study recommends the use of green cement with pozzolanic origin than only Portland cement as a way to maximize sustainability in building projects. Second, to show that clay processed at a temperature between 600 degrees Celsius and 900 degrees Celsius is conducive to make clay minerals reactive with Portland cement. And lastly, to identify the application of the chemical admixture is necessary to improve the flow properties of the green cement. Like I said before, this study will conduct using laboratory tests, which is setting time, compressive strength, and shrinkage. This is the result for setting time test. CO entry is a Portland cement, while PC3 is a green cement. As you can see, initial and final setting time for PC3, which is green cement, were delayed compared to CO3. It is because processed clay at temperature 800 degrees Celsius behave as a pozzolans. Pozzolanic materials usually have slow nature of reaction with the Portland cement. This is the result for compressive strength. This test is between the two cement show the strength achieved was statistically insignificant. This means that there are no significant difference in terms of strength at the standard curing periods. The use of green cement is very much suitable for any working place of Portland cement. This table is show that the compressive strength of Portland and green cement. At all curing periods, the strength of the green cement performed better than Portland cement. The results show that the pyroprocessed clay material behave as a filter at the early curing periods of 3 and 7 days. The behavior of the material after 7 days also show the pozzolanic effect of the processed clay. Pozzolanic effect takes up lime to form secondary hydrated compounds including calcium aluminate and calcium silicate hydrates that enhance the strength properties. The total shrinkage and the autogeneous shrinkage between the two cements were not statistically different from each other from the result. It could therefore be inferred from that green cement could be an alternative cement to Portland cement without any form of threat to its durability in terms of shrinkage. How findings were interpreted in this article. The basic step is, firstly, put raw clay that was ground into powder in a ceramic bowl. Then, place in an electric furnace for pyroprocessing at a temperature of 800 degrees Celsius for 2 hours. After 2 hours, the furnace will shut down and the ceramic ball and its content will allow to cool for about 24 hours later inside the furnace. For setting time, it is performed in accordance with ASTM C187 and it uses the VCAT apparatus. The cementitious binder was fed through an iterative method, which is using the water to cement ratio of the Portland cement system as a basic. Further varying the dosage addition of the superplasticizer after obtaining the consistency for Portland cement. For compressive strength, the findings were interpreted by performed in accordance with ASTM C109. Two metallic cobalt mold were cast from mortar cubes and it covered under wet burlap and plastic rubber for about 24 hours, and it will produce 6 specimens from each batch of the mortar. Lastly is to find finding were interpreted for shrinkage. It is performed in accordance with ASTM C596. Then, 6 mortar prisms were cast with each prism mount having the dimension of 25 mm by 25 mm by 285 mm. Next, the specimen were covered with a transparent plastic sheet and mouse burlap to prevent the evaporation. After 24 hours long of moist curing, the specimen were demolded and divided into 2 groups. So, a total of 3 specimens each were designed for total and autogeneous shrinkage. After that, the specimens were designed for total shrinkage test, were placed under curing water for about 72 hours after their lengths were recorded, while specimens designed for autogeneous shrinkage were sealed with wax and exposed in an environment chamber. Then, lastly, the unsealed sample of the lime water curing were also exposed to the condition in the environmental chamber.
So, from the article 1, we make discussion based on the question given. For the first question, how well the studies address the research question? Were there any limitation? So the answer is, based on the research question, the study were conducted in 2 methods, which is laboratory method and field method. So in laboratory method are divided by 3, which is normal consistency and setting time, compressive strength, and shrinkage. Next, for the field method, field application with green cement were conducted. So from the experiment conduct, the research question answered. So the limitations is the experiment take time to be done for curing. So for the next question is, how accurate were the results? Are any of the results convincing? So based on the result given, for normal consistency and setting time, PC3 require high content of the admixture to achieve the desired consistency compared to CON3. So PC3 is green cement and CON3 is Portland cement binder paste. So both initial and final setting time of the PC3 were delayed as compared to the Portland cement binder paste. For the compressive strength at all curing period, the strength of the green cement performed better than the Portland cement. Um, the day day 3, day 7, day 14, and day 28. Curing of the green cement attained 19%, 11%, 19%, and 30% strength higher than the control respectively. So We continue the answer from question 2. Next, for the shrinkage is divided by 2, which is total shrinkage and autogenous shrinkage. In general, total shrinkage occurs as a result of the loss of evaporable water between the semen-based material and the environment at a specific relative humidity and temperature, whereas autogenous shrinkage is caused by reduction in pore relative humidity as a result of hydration products formation. So from the figure, the total shrinkage of the mortar was higher than the autogenous shrinkage. So the figure can be looked at the slide before, maybe at the finding. So from the figure, the total shrinkage of the mortar was higher than autogenous shrinkage. The total shrinkage and the autogenous shrinkage between the two semen were not statistically different from each other. It could therefore be inferred from here that green semen could be an alternative semen to Portland semen without any form of threat to its durability in terms of shrinkage. So the result is very accurate to the main result of these studies. The experiment of comparison strength between green semen and Portland semen convincing that the strength of green semen performed better than Portland semen. So for the third question, what aspects of the research work were unclear? Based on the studies, we cannot find the aspect of the research work were unclear because all the experiment and the result was given. In this article, there are 4 types of experiment running, which is normal consistency and setting time, compressive strength, shrinkage, and field application with green semen. From this article, the result given is clear and easy to understand. So for the last question is, how do the studies going to contribute to development of future sustainable product? So the answer is the studies show that green material also have good quality of product. As we know, when producing ordinary Portland semen, it can lead to air pollution. Green semen can reduce semen intake. The green semen manufacturing process helps maintain semen strength. Other than that, green semen also can reduce porosity and enhance mechanical strength. That's all. Thank you.
So for the article 2 is a study of high strength fiber reinforced concrete by using 2 types of fibers. Okay, so overall article 2 is about high strength concrete. The use of high strength concrete is increased nowadays. It observes that high strength concrete relative brittle material fibers are added to improve its ductility. Experimental study is carried out to assess mechanical properties of high strength fiber reinforced concrete. So for the article 2 is about how to improve its ductility to make the material is suitable and stronger. From the article, we get that the research question is about what is the mechanical behavior of high strength fiber reinforced concrete. Okay, for the objective is to study the mechanical behavior of high strength fiber reinforced concrete. And next is to assess mechanical properties of high strength fibrous reinforced concrete. Okay, how studies were conducted. So, they use laboratory test, which is they use compressive strength, split tensile strength, and visual strength. So they use this kind of test to know the high strength of concrete. So this is the result, which is compressive stress. Uh, they can take the they know the fiber volume fraction and compressive strength at 28 days. So basically, the the day that they for the result is the first one is split tensile strength. So when we do the experiment, we can get the volume fraction and the tensile strength at 28 days. The second test is visual strength. So after we do the experiment, we also get the value fraction and the visual strength. For the next result is effect of fibrous content and visual strength of high strength concrete. Uh, the higher compressive strength and ductility are the most important parameters in the design of RCC structure. However, it is observed that the ductility of concrete reduces with higher compressive strength. Inclusion of fibers may erase the crack and improve tensile strength of concrete and thus ductility. Okay, so this is the first one, which is the compressive strength. We can see the graph increase and decrease after the value fraction is reached at 3%. So the second test is split tensile strength. This is the graph, and then the next is visual strength, and this is the graph after we get the data and we plot in the graph. Okay, next is how finding were interpreted. So basically how the data can get. So the first one is it's designed by DOE method, and second is silica foam was added as 5% weight of cementitious material. Next is meanwhile for fly is by 10% weight of cementitious material. And the last one is they are using the type of fibers, which is polypropylene fibers and flat steel fibers with different dosage of fibers. So next is how each experiment is conducted. Okay, for the first is compressive strength. Okay, the first step is the cube specimen of dimension 100 x 100 x 100 mm was placed in concrete laboratory. So the first step is we must make the specimen into a cube. So after that the total of specimen that we use are 51. So we do that much because if anything happen, we also have safety stock. After 24 hours of casting, the specimen will demount and transferred to curing tank for 28 days. So basically, the we let the specimen for 28 days. After 28 days, we can know the strength. The last one is the specimen will test under compression testing machine. For the next test is split tensile strength. So, uh, for the compression strength, we use cube. Meanwhile, for the split tensile strength, we use cylinder specimen of dimension 100 x 200 mm in the concrete laboratory. So, then the second is we do the specimen about 51 because if they are no if they are have a group, we can use the others. So after 24 hours of testing, the specimen will be mounted and transferred to curing tank for 28 days. Next is specimen will conduct testing under unisel testing machine. The others is visual strength. For the visual strength, we use prism of dimension 100 x 100 and times 500 mm. After 24 hours of casting, the specimen will demount and transferred to curing tank for 28 days also. Seems like the other aspect test, we curing tank for 28 days. For the visual strength, we test under a unisel testing machine.
Discussion for Article 2. How well the studies address the research questions? Were there any limitations? Based on the research questions, the researchers did well with studies by applying three types of tests, which is compressive strength, split tensile strength, and flexural strength. All the tests were done well and all main points was pointed out. There were no limitations during the research as all the materials were easy to find in the area. Next, how accurate were the results? Are any of the results convincing? A three-tests were conducted with 51 casted concrete and the average was calculated. The research accuracy was emphasized in this research. The result was convincing because the data that we taken is from average, so the results were more accurate and convincing. What aspects of the research works were unclear. Based on the studies, the only things that they did not show is the full results of the experiment. But actually it's not some big problem because the full average results were shown. Other than that, all the data, findings and results will state clearly. How do the studies going to contribute to the development of future sustainable product? The study shows that the fiber can change the brittlement of failure of a concrete into a more ductile one and improves the concrete ductility. The 3% to 3.5% improvement of flexural strength, compressive strength, and split tensile strength that using fiber is better than compared to the concrete that using chemical. Okay, for the conclusion, from Article 1, we can conclude that the usage of greener materials could be an alternative for binding material to Portland cement in order to maximize sustainability. Even though we used the clean cement, the strength performance was similar to Portland cement at all ages of curing time. This will make a big contribute to the earth. For Article 2, we can conclude that the fiber can bring a great effect to the cement, especially the cement strength. This is good for the high Portland cement, high strength Portland cement, because we can reduce the usage of chemical to do the high Portland cement. Okay, that's all from us. Thanks for watching. Have a nice day. Assalamualaikum.